In the next two videos, we're going to focus on special right triangles, the 45, 45, 90 degree triangle and the 30, 60, 90 degree triangle. Now this will be part one, so we're going to focus on the 45, 45 right triangle. And this will be important in geometry and even more important in trigonometry to find exact values of trigonometric functions of certain angles. So look at the first one. We have one angle is 45, the other one is 45 also. So this angle right here, of course, is obviously 90 degrees. You look at the second triangle, you got 60 for one angle, 30 for the other. Obviously this one is 90 degrees then. Don't have to put it in there. You should figure that out. And again, the focus will be on the 45, 45. So it should be clear that this side and this side have to be the same measure. This is a right triangle, but it's also an isosceles triangle because the base angles are 45, so that tells me that these legs of the triangle have the same measure. So if I make this a 1 here, I can go 1 unit over, 1 unit up. For isosceles, I can pick any values I want, and then I can find a third side here using the Pythagorean theorem. So C is always the length of the hypotenuse, which is the longest side of the triangle, always opposite the largest angle, which is 90 degrees. And then this side is A, and this side is B. Those are the legs of the triangle. And I know then from this formula that the square of the hypotenuse is always the sum of the squares of the other two sides. So C squared is equal to 1 squared plus 1 squared. So this tells me that C squared then is equal to 1 plus 1, which is equal to 2. Solve for C. Take the square root of both sides. Since we're dealing with lengths here, we have to have just positive values, so C will be the square root of 2. Now notice, if I make this an x and this an x, then C squared would equal to sum of the squares of the legs, which would be x squared plus x squared. So this will be 2x squared. Solve for C then, take the square root. So C will be the square root of this right here. The square root of 2 is going to stay the square root of 2. We'll leave it as the exact answer. And the square root of x squared would be x. So there you have it. This is this side. If this side is x, the other side is also x, and you have this type of triangle, or again, this is 90 degrees here, then the hypotenuse will always equal to the length of one of the legs, doesn't matter which because they're the same length, multiplied by the square root of 2. So in geometry you work several types of problems where this concept comes into play, either a 45, 45, 90 degree triangle or a 30 degree, 60 degree, 90 degree triangle, and never lose track of Pythagorean theorem. So you'll be using this in conjunction with these triangles. So let's look at what this is telling us. This tells me then if I have a 45, 45, 90 degree triangle, and I know the length of the one side, which of course is the same, to get the hypotenuse, I just multiply either side by the square root of 2. It also tells me that if I know the length of the hypotenuse, and I want to get one of the legs, the length of one side, I simply divide this length by the square root of 2. And let's look at some basic examples. Find the value of x. This is what we're given. This side is 3. This side is 3. And of course you can see you have a right triangle. So these angles have to measure 45, 45, and say we're looking for the length of the hypotenuse. Now keep in mind that you could use the Pythagorean theorem, but with what we just went over, all you would have to say is x is equal to whatever the length of one side is times the square root of 2. Now, if you want to use the Pythagorean theorem, you can. You can just say the length of the, or the square of the hypotenuse, which is x, is equal to the sum of the squares of the other two sides. So 3 squared is 9. Another 3 squared is 9. That's equal to 18. So now we solve for x. We take the square root. X then is equal to the square root of 18. And then you always want to simplify these radicals. Now if they ask you for an approximation, then you can use your calculator and take the square root of 18 and give an approximate answer. But if they don't say, you can just give the exact answer here. So 18 is 9 times 2. And we can bring on the 9 because the square root of 9 is 3. So this gives me 3. And the 2 stays under the radical. 3 square root of 2. And that's your answer. So again, you can use the Pythagorean theorem, c squared equal to a squared plus b squared. That is, the square of the hypotenuse is always equal to the sum of the squares of the legs, which are also, which of course the sides of the, or the length of the sides of the triangle. Look at this one then. Let's suppose that, okay, we want to find x, and this side is 4 times the square root of 3, and this side is also 4 times the square root of 3. And say again, we're looking for the length of the hypotenuse, which is x. So if we use the ideas we just went over then, the length of the hypotenuse will simply be the length of one leg. They're both the same. In this case, we have a 45 triangle. Both sides the same length here. So the angles are 45 degrees. And then we multiply this by the square root of 2. So again, radical, you can multiply the radicands there, so it'll be 4. And then the square root of 3 times the square root of 2 is the square root of 6. This is your exact answer. Now again, if you want to approximate this, just take your calculator, and you'd have 4 square root of 6, and we get 9.79, 7, and so on. You can run that out to one place, 9.8. Or again, they might ask for the exact answer. The exact answer in this case is 4 times the square root of 6. Suppose again we have the problem, find the value of x. And let's say this is 8 here, and this is x. And this is also x. So again, it's a 45, 90 degree triangle. These angles are the same, 45 degrees each. We want to find x. So to get the hypotenuse, knowing the leg or legs, we multiply by the square root of 2. So we know the hypotenuse and we want to find one of the legs, we can divide it by the square root of 2. Or we can set it up this way and say, based on what we've done, 8 should equal to the length of one leg, which is the unknown, multiplied by the square root of 2. Then you can solve that equation for x. So let's divide both sides by the square root of 2 and the square root of 2. This divides out. So x would equal to 8 over the square root of 2. Now in general, the instructor is going to want you to simplify any expression with a radical. So if you have something like, if the answer is something like the square root of 50, your instructor is going to want that in simplified form, so you don't want any squares in the radicand. So you'd want to simplify this and say, well, 50 is 25 times 2, and the square root of 25 is 5, so that comes out. So square root of 50 can be written as 5, and the 2 stays under the radical 5 times the square root of 2. That would be a simplified form of that. In the same way, we don't want to leave a radical in the denominator. So the best way to do that is to make this radicand a perfect square here. So if I multiply square root of 2 by the square root of 2, that's going to give me the square root of 4, which is 2. But I have to do the same thing up here. You multiply the denominator by the square root of 2, multiply the numerator by the square root of 2. Then it's legal, because if you look at that, the square root of 2 divided by the square root of 2 is 1. So I'm not changing the problem. Whereas if I multiply the denominator only, I am changing it. This is still 1. So in this case, this gives me 8 times the square root of 2. And this is, multiply these out, since it's both square roots, this gives me the square root of 4. Square root of 4 is 2. Now I get this. Then I can do, you don't want to divide this 2 into that one, because that one's under the radical, this one is not. So you can divide these two, 8 and 2. So 8 divided by 2 is 4. So the answer comes out to 4 times the square root of 2. Okay, in the next video we're going to look at the 30, 60, 90-degree triangle, along with more complicated examples from this particular video. Thanks for watching. We'll see you next time.